this program, we'll see how two teachers are using their interactive whiteboards to help teach abstract science topics.
It still can go round the other way.
Ali Goff is teaching a module on electricity. But in the first part of the program, Jane Chalmers is introducing a new module on space to her class of Year 6s in her small village school outside Oxford.
Right, first lesson on the solar system. You've seen these concept cartoons before.
To begin the topic, Jane presents the class with concept cartoons on the whiteboard. These statements, some true and some false, are designed to prompt discussion and test the pupils' prior knowledge of the topic.
Mars is the closest planet to Earth. Who had a discussion about that?
We think that Venus is the planet that's closest to Earth.
I will actually tell you, Annika, that you are absolutely right. I particularly like concept cartoons. It's a very interesting way to listen to the children and hear their responses and find out what their misconceptions are and what they know before we start a new topic.
As a starting point, the students look at the order of the planets in our solar system, giving each its correct label on the whiteboard.
Sometimes it's nice for the children to come up to the board and move things around for themselves. Just having somebody else, perhaps one of their peers, doing something instead of watching the teacher all the time keeps them interested and motivated.
Next, to give the pupils a further mental image of the size of the planets and the distances between them, Jane shows them an animation.
And what you're going to watch is travelling out from the sun towards the outer reaches of our solar system, past all the planets. Now I'll pause it as we fly by each planet and see if you can remember the names of them. Okay, here we go. So there's the sun. Right, there's the first one. What was that?
Is it Mercury?
Well done, Joey, you're absolutely right. And the next one?
Is it Venus?
It is, Ella, well done. So what's going to come next? Victoria?
Earth.
Earth, good girl. The video clip was really useful because that began to get across the sheer distance there is between each of the planets, and that's something I can't do with static pictures on the interactive board.
It did kind of help because it showed us how far away some of the planets were from the other planets and how big they were.
Even though that film isn't made to scale, it gives you some idea of just the enormous space that we're talking about. I'll ask the question again.
In the next part of the lesson, Jane uses further animations to discuss day and night.
Right, I wonder, can you tell me, if I was standing right there, would it be dawn or dusk? Annika?
It would be first thing in the morning at dawn.
You're absolutely right, it would be first thing in the morning. Can you explain to me why?
Because the Earth is going to turn around facing the sun, so then it will be the daytime.
Good girl. What I want to talk to you about now is an eclipse. This is a solar eclipse, and what happens is we have the light coming out from the sun in different directions, but what happens to the light when it gets to the moon here?
The light tries to shine down on the Earth, but the moon is blocking the way of the light going to the Earth.
You are quite right. Because the moon is opaque, it's blocking the light from the sun, and this side of the moon is in darkness. So we see...
As a way of reinforcing the scale of the solar system, Jane introduces a cartoon figure in a plane flying between the planets at 900 kilometres an hour.
So we've got a little chap here, and he's going to fly on his jumbo jet from Earth to each of the planets in turn. Just like that. I want to know how long it would take to get on his little 747 jumbo jet all the way from Earth out to Pluto. One of the difficult concepts to get across to children is just how far away these planets are. So I think it's quite interesting to illustrate that by suggesting that if you went on an aeroplane, how long would it take?
The pupils are guessing the length of the journey. How many years do they think it'll take?
1,050 years to get to Pluto.
Would you think it's more than 1,000 years?
I don't know. If it was 1 billion, then you'd die on the aircraft.
Right, now that you've had a chance to talk about it, let's have a few estimates.
We thought it would be 150 years.
Okay, well done.
We thought it would be 900 years.
You think it'll take about 900 years? Okay.
175?
175 years.
Having made their predictions, the pupils draw their own diagrams of the Earth's rotation and solar eclipses into their books, discussing what they've learnt.
I think it would be that side.
773.
The more able pupils are given each planet's distance from the Earth. From that, they work out the time it'll take, in years, to fly there in the jumbo jet, travelling at 900 kilometres an hour.
So you can take off the 2 zeros from 900 and take off 2 zeros from 4.3 billion, divided by 9 to get you today.
When they've worked out the distances, they tell the rest of the class. Whose prediction for the time it would take to fly to Pluto is the closest?
Pluto? It would take 542.8 years. The closest estimate was Ella and Charlie's. They guessed 350 years.
The pupils have some idea of the speed at which an aeroplane travels. Rather than use a space rocket, by using this rather more familiar measure, Jane is able to give her pupils a better understanding of the time and distance involved in travelling between the planets.
545 years, for example, to Pluto is something that an 10 or 11-year-old has some concept of how long that is. I was absolutely fascinated when I worked this out myself, that on a jumbo jet it would take over 500 years to get to the last 2 planets. An interactive whiteboard is fantastic at teaching the abstract areas of science that are difficult to teach, because of course I can't bring a planet into the classroom.
Ali Goff is a Year 6 teacher in Yeovil. She's currently teaching a module on electricity. In their last lesson, the class looked at examples of different conductors and insulators. To start today's lesson, she's using the interactive whiteboard to visually recap this.
Can anyone come and help me sort the conductors and insulators? Glenn, would you like to come and move one for me, please? Well done, thank you. Wood is an insulator, electricity cannot pass through it.
It's really nice if you can make the presentation look really bright and colourful for the children, just as a motivational thing.
Well done, metal.
Moving the lesson on, Ali tests the pupils' existing knowledge of electrical symbols, getting them to draw components that she reveals on the whiteboard.
Okay, can you write me electrical symbol for a motor, please? Fantastic, thank you very much. Circle, which is a resistor sign with an M in it. Brilliant. Okay, can you draw me the symbol for a battery of 3 cells? Wonderful, thank you.
Ali then looks at how these components connect together in a circuit. To do this, she presents the pupils with circuits that may or may not work.
Here is the circuit. Has the bulb lit up? No. No. Can you put your hand up if you think it's not working because the batteries are facing the wrong way? That is pretty conclusive. Well, let's have a go. If I take out one of these batteries and put in another one, I'm going to join it up and hopefully it will work. Okay, now this was my favourite one. Do you think that that is a circuit?
No, because the battery's not powerful enough to operate make the bulbs and the buzzers work.
Okay, let's have a look at the circuit. Now there it is. Are the bulbs working? No. Are the buzzers buzzing? No. Now, you are spot on. It's because the battery isn't powerful enough. I had a go, and this is how many batteries I had to put in to make it work.
For the practical part of the lesson, Ali's divided the class into groups. They have 20 minutes to build a range of circuits.
And off we go.
Each group has a box of components and a worksheet showing the different circuits that they must make.
4 wires and 2 batteries to make the A circuit. So that's what you have to make, really.
Okay, Melissa, so have a look at the picture. How many batteries do you need? Okay, and how many bulbs? There we go.
Put that one on the floor.
Hey, now,
It's getting dimmer.
the bulbs are a lot dimmer, aren't they?
Yeah, but on the next one, it gets brighter.
The 20 minutes are up. Ali goes back to the interactive whiteboard to explore why some circuits produce dimmer bulbs than others.
Now, Ellie, I need you to make me up a really simple circuit that's got a battery, 2 bulbs, and a switch. Right, and my battery, put that down the other end so it's nice and balanced, thank you. And the switch. Now you need to flick the switch for me. Can you flick the switch? Click on him. There, now, Ellie has made what's known as a series circuit. Now, the electricity flows around the circuit. Now, when I take out one of those bulbs, it makes a block, and the electricity can't get through.
Next, she gets another pupil to build her a parallel circuit.
Okay, now, George, I want you to make me a circuit that has a bulb on these 2 different wires. Same with the switch and the battery, but I want a bulb on different wires this time, not on the same one.
I used an interactive program that showed the brightness of the bulbs and also the electricity moving around the circuit. So once we put the components in, you could actually see the flow, and it makes it much easier for me to explain about blocked pathways and about the amount of current getting to the bulbs.
Now, that's called a parallel circuit, and this one is called a series circuit. Look at the brightness of those bulbs as opposed to those bulbs. Which bulbs are brighter, the first circuit or the second one? You're right, the second one is brighter.
To finish off the lesson, Ali splits the class into 2 teams to play a game on the whiteboard. The pupils pair up pictures of different components and their matching symbols to score points for their team.
Jake, you need to come up and move 2 of the tiles. It just gets all the children involved, and as well as, being a small assessment tool, allowing me to check, the understanding, do they know what's, when they have a pair. Also, it's bringing the fun in and keeping children enjoying science.